Welcome back to another Marcus Maths video. Today we're going to be going over some hidden and second order derivatives, so important skills, but it's not going to be as complex as the skills that we were learning about in last video with those complex differentials. So highly recommend you check out that one if you haven't already as a precursor to this video, but let's go ahead and get started. Make sure to like and subscribe to the YouTube channel for more AP Calculus BC content. And let's get started with this first question. So we need to recognize that this is a hidden derivative. So it's going to be a function here. We're going to use what we know about the definition of the derivative to figure out the function. And then from there, we're just going to take the derivative of that function, which is the same as finding the limit as h approaches 0. So if we don't know already how these work, the definition of the derivative is f parentheses x plus h and then minus f of x over h. So, and remember, we actually have an x value here. It's pretty simple to see that our x is going to be equal to 2, since that's the only thing inside the parentheses. Then we can see our function, when we remove the 2 and we replace it with the x, we see our function is 3x to the power 4. So, the function f of x is simply 3x to the power 4. And then we know our x value is 2, so we're going to take the derivative of 3x to the power 4, which is 12x to the power 3, and we're going to just substitute back in our 2. 2 to the power 3 is 8, 8 times 12 is 96, so C is the correct answer with this one. Okay, moving on to the next, we're going to find the second derivative of this right here. The 2 is going to have no impact, it's just going to carry on. And then the derivative of cosine, notice we're going to have a chain rule here, because outer function is cosine. Derivative of cosine is negative sine, so we have negative 2 sine of x over 2. And then we're going to multiply that by the derivative of the inside function, which is 1/2. Negative 2 times 1/2 is negative 1, so we are left with negative sine of x over 2, and that's our first derivative. Now we have to find our second derivative, which is what these two apostrophes show us. We're going to take the derivative of this. The negative doesn't change. Derivative of sine is cosine, so we are left with negative cosine of x over 2. Once again, chain rule, multiply by 1/2. So we're left with negative 1 over 2 cosine x over 2, which is equal to answer choice C. Always make sure that you're doing those second derivatives, because after that first one, you might feel the need to stop. Okay, we're going to find the second derivative here of an implicit function. So these are actually quite calculation dense. So let me show how to do this one. Well, it's exact same to find the first derivative. Second derivative, though, is going to be a little bit different. So we know how to work these. We did them in the last video. We have 4y to the power 3. Whenever you find the derivative of y, make sure to include a dy over dx. And then we find the derivative of 5x, and that's just 5, is equal to 0. Move over to 5, it's negative 5. Divide both sides by 4y over 3. So you're left with negative 5 over 4y to the power 3 is equal to dy over dx. So this is our first derivative. Now to find our second derivative, we have to differentiate this. Now you may notice that this is a product rule right here. But we could actually rewrite this a little bit to make it a little bit more digestible. We can write this as negative 5 over 4 times y to the power of negative 3. Now you notice we don't have to worry about quotient rule anymore, and we can just, since it's multiplying with a constant, we don't have to do product rule. We can just take the derivative of y to the power of negative 3. We know that's negative 3 y to the power of negative 4, so y is just going to be in the denominator with a 4. So we're just going to multiply our constant, negative 5 over 4, with negative 3 over y to the power 4. We get 15 over 4y to the power 4. And we need to remember, whenever we take the derivative of y, we have to include a dy over dx. So this is always multiplying with a dy over dx, in fact. So that means our second derivative is 15 4y to the power 4 times dy over dx. Notice we have a dy over dx. We can just substitute that back out with what dy over dx is equal to. And we know that that is equal to negative 5 over 4y to the power 3. So now our second derivative is this. So let's go ahead and simplify. Negative 5 times 15 is negative 75. So our numerator is negative 75. Our denominator is 16. And y to the power of 7. Okay, and now we're going to substitute in just 1 here, because we don't have any x values to substitute. So we have negative 75 over 16 is the correct answer. We can not simplify this fraction. Alright, so that is the correct answer. Implicit differentiation with second derivatives are going to be a little bit difficult. If you have any further questions, let me know in the comments. Okay, another hidden derivative here. We just need to know our function is 5 arcsine of x. And we know that x is equal to 2/3. Very similar solving formula as beforehand. And now from here, we just need to know, okay, what is the derivative of inverse sine of x? So, and we know we're going to just multiply 5 with that derivative. So if you remember from the previous video, we should know all these inverse trigonometric derivatives. And for inverse sine, it is 1 over the square root of 1 minus x squared. In this case, of course, we don't have to worry about any chain rules, so that just makes this more simple. We have 5 on the numerator, and then square root of 1 minus x squared in the denominator. We're going to substitute back in 2/3. 2/3 squared is 4/9. 1 minus 4/9 is 5/9. So we have 5 over the square root of 5/9. Notice we're going to have to simplify this, because it doesn't match any of the answers. 5 is in our numerator. Denominator is now square root of 5 over square root of 9, which is 3. And now we have 5 over square root of 5 over 3. We can turn this into horizontal notation. 5 divided by, with this sign, square root of 5 over 3. You might remember in 4th grade, key change flip. 5 times 3 over square root of 5, which you have 15 over square root of 5. Now we have to rationalize the denominator, algebra 1 stuff, multiply by a fraction of square root of 5 over square root of 5. Notice that our denominator will be equal to regular 5, and our numerator will be 15 over times square root of 5. Now from here we have to simplify the fraction. 15 over 5, 15 divided by 5 is 3. We simply left with 3 square root of 5. So after a lot of manipulation to that answer, we get answer choice A is the correct one here. Moving on to our next question, we have h of x is equal to log of x, and we're trying to find the second derivative of log of x. Notice that whenever we're referring to these, the base is a. We're going to just set this equal to 10 very soon. But the derivative of a log is 1 over x natural log of the a. Natural logs are a lot more helpful in calculus. So a is equal to 10, so that means we just substitute out with 10. This is our first derivative. Now we have to find our second derivative. Remember, ln of 10 is simply a constant value. So we're going to multiply 1 over ln of 10 with our answer. And then, well, with our other part, which is 1 over x. Now we just have to find the derivative of 1 over x. Because when we're multiplying, we can just move that on the outside of the derivative. That's one of our rules. So this is x to the power -1. We move the -1 in front. It turns into x to the power -2, which means it's on the denominator and it's to the power 2. So we can now erase the 1 over x with -1 over x squared. And now we can just multiply. 1 times -1 is -1. And then we're going to have x squared ln of 10, natural log of 10, in our denominator. So that means the answer choice D is correct, finding the second order derivative of the log of x. And that is the final correct answer with this question. More simple. We were just discussing using a little bit of our complex differentiation knowledge and just doing that twice over. And also referring back to the definition of the derivative that we learned in Unit 1. Definitely stay tuned on the weekend. I'll do a video for Unit 3 full review. But definitely look forward to that. I will see you guys then. Have a good rest of your evening and goodbye.